Hello everyone. In this video, we are going to discuss how to determine sum of the terms of a given arithmetic sequence. An arithmetic series is the sum of the terms in an arithmetic sequence. For example, if we have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5 as the first 5 terms of an arithmetic sequence, when we are going to add them, we form an arithmetic series. For example, find the sum of the first 10 counting numbers. This means we are just going to add the first 10 counting numbers. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, and so on and so forth. And the answer here is 55. So adding the terms in an arithmetic series will be a very hard work for us to do, especially if our list is just too long. Now, to devise a way to make things easy, we will consider this method here. S sub 10 equals 1 plus 2 plus 3 and so on and so forth. And then if we do the reverse order, S sub 10 equals 10 plus 9 plus 8 plus 7 and so on and so forth. Then adding these two equations, we have S sub 10 plus S sub 10 equals 2 S sub 10, and 1 plus 10 is 11, 2 plus 9 is also 11, 3 plus 8 is also 11, and so on and so forth, such that the last pair 10 and 1 will also give us the sum of 11. So notice here that 11 appears 10 times. 10 times because there are 10 terms. Now dividing both sides by 2, so we have S sub 10 equals 10 over 2 times 11. This n here is the number of terms, and this 11 here is the sum of a sub 1 and a sub n. Our formula is S sub n equals n over 2 times the quantity a sub 1 plus a sub n. Now, let us make a generalization. Let a be our first term, and d be the common difference, and n be the number of terms. So to find the sum of n terms, it's the first term a, the second term is a plus d. So the second term is obtained by adding d, or the common difference. Then the third term is obtained by adding the first term and twice the common difference, and so on and so forth, such that the last term is a plus the quantity n minus 1 times d. Now if we will reverse the order, so we have S sub n equals a plus the quantity n minus 1 times d. This is the last term here, it becomes our first term here, and so on and so forth, and our last term here is actually the first term on our first equation. Now adding the two equations, S sub n plus S sub n equals 2S sub n. So adding also a plus the quantity n minus 1 times d, this is what we get, 2a plus the quantity n minus 1 times d. And also if we are going to add a plus d and a plus the quantity n minus 2 times d, this is also our answer here, same with what we have here. And adding this pair here will also give us the same answer. This common answer we get appears n times. So if we have 20 terms, it will appear 20 times. So if we have 100 terms, it will appear 100 times. So now dividing both sides by 2, we have S sub n equals n over 2 times the quantity 2 a sub 1 plus the quantity n minus 1 times d. So this is the second equation we have. So we have to use these two equations in solving problems that involve arithmetic series. Now they are related. How? So we know that the formula in finding the nth term in an arithmetic sequence is a sub n equals a sub 1 plus the quantity n minus 1 times d. Now substituting this part to our a sub n here, this is what we will get. And notice that this a sub 1 plus a sub 1 is equal to 2a sub 1. So these are our formulas. Now for me, it's easy to use the second one because we will just find the first term and the last term, then multiply the sum by n over 2. Now let's do an example. Find the sum of the first 20 positive odd integers. So the first 20 positive odd integers, 1, 3, 5, 7, 9, the 20th is 39. So we have here n is 20, a sub 1 is 1, and our a sub n is 39. So our formula is a sub n equals n over 2 times the quantity a sub 1 plus a sub n. Okay, 20 over 2 times 1 plus 39. Now simplifying furthermore, we have 20 over 2 times 40, and then our answer is 400. Example number 3, find the sum of the first 200 positive even integers. So the first even integer is 2, then 4, then 6, then 8, then 10, and the 200th term is 400. So a sub 1 is 2, a sub n is 400, and our n is 200. So this is our formula. A sub n equals n over 2 times the quantity a sub 1 plus a sub n. Then substituting these values to our formula, this is what we get. 200 over 2 times the quantity 2 plus 400. Then simplifying furthermore, we have 200 over 2 times 402, and the answer is 40,200. Example number 4. Find the sum of 15 terms in a sequence if the first term is 7 and the common difference is 5. Here, we do not know the 15th term. So to find the 15th term, we can use this formula. A sub n equals a sub 1 plus the quantity n minus 1 times d. Okay, a sub 1 is 7 and n is 15 and d is 5. So substituting these values to our formula, we have a sub 15 equals 7 plus the quantity 15 minus 1 times 5. Now simplifying furthermore, we have 15 minus 1 times 5 equals 70, and 7 plus 70 equals 77. So this is our 15th term. Now we can use the formula. A sub n equals n over 2 times the quantity a sub 1 plus a sub n. Okay, we have n 15, a sub 1 7, a sub n 77. Simplifying furthermore, we have 7 plus 77 is 84, so we have 15 over 2 times 84, and 15 over 2 times 84 equals 630. So this is the answer. Now, your turn. I prepared here 5 problems, and the 3 are just straightforward problems. Number 1, find the sum of the first 20 positive multiples of 5. Number 2, find the sum of the 21 terms in an arithmetic sequence whose first term and last terms are 23 and 793 respectively. Number 3, there are 23 terms in an arithmetic sequence. Find the series given that a sub 1 equals 7 and t equals 4. So you can pause the video and work on these 3 problems. I have 2 more problems here, and they are challenge questions. Okay, number 1, find the sum of the 25 terms in an arithmetic sequence if the last term is 305 and the common difference is 9. Number 2, given that d equals 10, a sub 10 equals 29, and n equals 30, find s sub n. For item number 1, our answer is 1050, and these are the details of our solution. For item number 2, it's 8568, and these are the details of our solution. And for item number 3, the answer is 1173, and these are the details of our solution. Now for our first challenge question, find the sum of the 25 terms in an arithmetic sequence if the last term is 305 and the common difference is 9. Here we do not have the first term, so we are going to find the first term first. So this is our formula: a sub n equals a sub 1 plus n minus 1 times d. So a sub n is 305, a sub 1, okay, that is what we're going to find, and n is 25, so 25 minus 1, and our common difference is 9, so times 9. So simplifying furthermore, we have 305 equals a sub 1 plus 216. So it's because 25 minus 1 is 24 times 9 is 216. 305 minus 216, so we have a1 is 89. So we can now use the formula s sub n equals n over 2 times the quantity a sub 1 plus a sub n. So substituting, so we have 25 over 2 times the quantity 89 plus 305. And simplifying furthermore, we have 25 over 2 times 394. And our answer is 4925. For the second challenge question, given that d equals 10 and a sub 10 equals 29 and n equals 30, find s sub n. So here we don't have a sub 1 and we don't have a sub n either. So we will find a sub 1 first. So this is how we devise it. This is a sub 10 and a sub 1 is here, and then a sub 30 is also here. So this is our formula to find a sub 1. So 29 is our a sub 10. So we have 29 equals a sub 1 plus 10 minus 1 times 10, our common difference. Simplifying furthermore, we have 29 equals a sub 1 plus 90. Subtracting 90 from both sides, we have a sub 1 equals 29 minus 90, and that is negative 61. Now we know the first term. We are now going to find the last term, or the a sub 30. So a sub 30 equals the first term, negative 61 plus n minus 1, and this time is 30 minus 1, then times 10, our common difference. So simplifying furthermore, we have negative 61 plus 290 equals 229. We have the first term, we have the last term. So we can use the formula s sub n equals n over 2 times the quantity a sub 1 plus a sub n. So substituting, we have 30 over 2 times the quantity negative 61 plus 229. Simplifying furthermore, negative 61 plus 229 is 168, and 30 over 2 times 168 equals 2520. This is our answer. Did you get all the items right? I hope you did. Thanks for watching, guys. This is Teacher Rejil. Keep safe.